Konnichiwa, students. This is Trivet, and we're looking at lesson 5 from chapter 6 today. This one is called the coordinate plane. Previously, we talked about graphing coordinates and graphing using a coordinate plane, but we focus on one quadrant, which was all positive numbers. Today, we're going to work on a little bit of negatives in there. So our learning target to start with says, I can identify and plot ordered pairs in a coordinate plane. And we should be on page 276 in our math journals, or excuse me, in our math books. So let's first take and write down our learning target. I can identify and plot ordered pairs in a coordinate plane. So the first thing we'll do is talk a little bit about the coordinate plane again. I know we've previously talked a little bit about this, but in your notes, if you could try and make a straight line better than I did. Do your best to make a line going straight vertically and then across horizontally. This would be called the coordinate plane. We're going to just jot down a couple vocabulary words here before we get started. The line that goes from right to left is called the x-axis, like we've discussed before, and the line that goes top to bottom is called the y-axis. This middle point right here is called the origin, and the ordered pair for the origin is 0, 0. So that's what we locate there. And then the last thing I want to talk about are the 4 different sections of the coordinate plane. They're called quadrants. And so this quadrant right here would be quadrant number 1. Then it goes around this direction. So this would be quadrant number 2, quadrant number 3, and they use Roman numerals to label these typically. This is quadrant number 4. So this is the Roman numeral for 1. This is the Roman numeral for 2, quadrant 3, and quadrant 4. And these are called quadrants. This is how you spell quadrants. So that's what we call those 4 sections. So we have usually been using in this grade level quadrant 1 because these are all positive numbers. We're going to talk about quadrant 2, 3, and 4 today and plotting more than just positive numbers. So when you see the words ordered pairs, I want you to think about when you see something written, for example, like this. That's called an ordered pair. So if I wanted to plot an ordered pair, this set of numbers would represent one dot on a coordinate plane. And remember that the first number in an ordered pair represents what you do on the x-axis. So that's what you do from right to left. And then the second number here represents what we do on the y-axis, and that's going up or down, depending on the number. So that's kind of our vocabulary for today's lesson. Now we can get to our examples. And having a grid journal is going to be a little bit helpful for you in this lesson, but if you don't have one, you can still do these notes. You just won't have the grid in the background to do them. All right, so getting to example 1, it just says identifying an ordered pair. So we're going to plot and identify these ordered pairs on our own system here. So let's make a y-axis, and then let's make an x-axis. And I typically try to make my x-axis and y-axis kind of the same length if you can, but make sure it fits on your notes. So for this one, it says, which ordered pair corresponds to point T? So we're basically just going to take a look at point T on the grid that they have in our book, and we're basically going to just plot it on our journals. So point T is sitting right here. If you look at their little arrows, it's sitting right here. So if you could please put a dot in your journals right at that point and label it T. You You can see how many over and down it is located at. We're going to just label its coordinates. So remember, we always start at the origin with our pencil when we're trying to find the ordered pair of something. From the origin, we have to move to the right and we have to move down. Anytime on a number line, remember that if you have to go from the 0 to the right, those are positive numbers. So I'm going to put a little plus sign there. Anytime you have to move to the left on a number line, you would go negative numbers. Remember, on a vertical number line, if we're going top to bottom or up to down, from the 0, if you have to go up, those are going to represent positive numbers. And from the 0, if you have to move down, those are going to represent negative numbers. So if I want to go to the right, that's going to be a positive first number. And then I have to go down from there. So that's going to represent a negative second number. So T's coordinates are ordered pair. I'm going to put my parentheses with my comma. I have to move on the x-axis 1, 2, 3 lines to get to the T. That's a positive 3 because I'm moving to the right. Then I have to go down 1, 2, 3. So that means I'm going to have negative 3 because I had to move down. And that's how to get to T, the same T that's on our journals. Let's go ahead and do some of the other ones as well, because those are actually the on your owns. The on your owns at the bottom of 276 ask you to try to do all the others. So let's make a dot right here on our coordinate grid. We're kind of doing the on your owns together today. That dot is going to be representing the S. So let's list the S. Let's do our coordinates, our ordered pairs, comma. Remember, we started the 0. And the first number represents what we do to the right or to the left. Notice the S doesn't move to the right or to the left at all. If that happens, then we put a 0 in this first slot. But it does move up, and it moves up 1, 2. Remember, up means positive, so we're going to put a positive 2 in that second slot. Next, let's put a dot right here on your journals, and we're going to label that one Q. And so we'll go ahead and list the ordered pairs for Q. Remember, we started this origin. This time, instead of going to the right, we actually have to move to the left. And so that's going to be a negative first number. So we have to move to the left 2 spaces or 2 lines. So it's going to be a negative 2. And then we do not have to move up or down to get to this Q. So we're going to say 0 for that second move. Our next point we're going to plot is going to be right here. Put a dot right there in your journals, and we're going to label that R. I'm kind of doing these out of order, but that's okay. From that origin, we have to move to the left, so our first number is going to be a negative. We have to move back 1 space to get to this R. So we're going to have negative 1 as our first number. Now we have to move down to get to the R, and we have to move down 1, 2, 3, 4. So this would be negative 4. So that's the ordered pair for R. And there is one more listed, and it's going to be right here. Put a dot right there in your notes, and we'll label that P, and we'll list the ordered pairs for P. So from this 0 origin, we have to move to the left, so our first answer will be negative. And we have to move negative 1, 2, 3 to get to P. And then we have to move up. Remember, up is positive, so we move up 1, 2, 3, and we have 3. So each of these numbers represents 1 dot on the grid. And we're finished with example 1, as well as the on your owns that connect with example 1. Now we'll go ahead and go to example 2. So we're going to make a new coordinate plane that we're going to plot some new dots on. So we have example 2. Try to do your best to make straight lines, and I will do the same. I'm going to circle that this is my origin. That's where I always start. Example 2 asks us to plot A, negative 2, 3, and B, 0, -3.5 in a coordinate plane, and describe the location of each point. So if I write down the two ordered pairs they want us to plot, A is listed as -2, 3, and B is listed as 0, -3.5. So we have something new here. We have a little decimal to deal with. Let's start with the A. Remember, our pencil goes to the center, the origin. The first number is -2. Remember, the first number tells me what to do, right or left. So I'm going to go to the left since it's a negative number. 1, 2. Then I have to do my second move, which says +3. Positive goes up, so I'm going to move 1, 2, 3. Now that I have done both moves, I know where my A is going to be located, and it's right there. I'm going to put an X there because my stylus doesn't do dots very well, so I'm going to just locate mine with an X. The next one says 0, -3.5. So 0 in the first slot means I don't have to move right and I don't have to move left. I stay put. The second number is -3.5, which means I'm going to go down 3.5 lines. Here's line number 1, line number 2, line number 3, and then a half would be right in the middle. So right here is where B would be located. And again, I'm going to put an X to mark that spot. And then they ask us to describe the location of each point. Well, for that, we could just say, well, point A is going left 2 lines and up 3 lines. Point B is just going down 3.5 lines because you don't have to move right or left. That's how you would describe their locations. And finally, we have our last example for this lesson. If you wanted to pause a video, 277 has some on your owns to plot, 5, 6, 7, and 8. You could practice plotting those 4. And then it also says describe the location, so you could tell me where they are. Another way to describe the location is to tell me what quadrant they are. So are they in quadrant 1, quadrant 2, quadrant 3, quadrant 4? Those are the same quadrants that we listed at the beginning of the lesson. So for example, this A right here would be in quadrant 2, and B is sitting right on the line. So if we were to say which quadrant that is, we actually would say it's just on the y-axis. We wouldn't say quadrant 3 or 4, we would just say on the y-axis. So pause and try the on your owns if you'd like, and then tell me what quadrant they're located in. Okay, if you tried number 5, you should say it's in quadrant 4. Number 6 is on the x-axis. Number 7 is in quadrant 3. And number 8 should be in quadrant 2. So now we can move on to the last example. This one's trying to get us to think more real-life scenario here. An archaeologist divides an area using a coordinate plane in which each unit represents 1 meter. The corners of a secret chamber are shown in the graph. What are the dimensions of the secret chamber? So dimensions, that word dimensions, is kind of asking us what are the length and width of this kind of secret chamber area they're talking about. So what we're going to do here is draw a y-axis and an x-axis and plot the secret chamber. Wow, let's try that again. Plot the secret chamber that they have listed for us. Yikes. So this is what they have in the book. They have kind of an x and a y-axis that aren't equal on all the sides because their secret chamber is all above the x-axis. So they have a dot at 2, 1, which ends up being right here, 2, 1. Then they have a dot at 2, 5, which ends up being about right here. They have a dot at -4, 1, which is right here. And then they have a dot up here at -4, 5. So as you notice, they create a little rectangle. So if you wanted to, you could connect all 4 ordered pairs to make a little rectangle. And the question asks, what are the dimensions of the secret chamber? So if we count up how many boxes long each of these lines are, this is 1, 2, 3, 4. This is 1, 2, 3, 4, 5, 6. So we have a 4 by 6 secret chamber. And if we look back at the original question, it says each little box represents 1 meter. So this would be 4 meters long and 6 meters long. So our dimensions, the length of the secret chamber would be 6 meters, and the width of the secret chamber would be 4 meters. So when you're trying to figure out dimensions or distance, you don't really worry about where the y-axis and x-axis are. You basically just look at your rectangle and you count up how many boxes long the lines are. So it really doesn't matter that these are in the negatives and these are in the positives. You just figure out how long is that line and how long total is that line. And then you've got one more on your own at the bottom of page 277 if you'd like to try that one out. Go ahead and pause now. Okay, and the answer to number 9 is 1 meter. That brings us to the end of that lesson.